Hey guys, this is my new Patreon tutorial. I wanted to cover, this has been asked actually a couple times by some people, to cover instancing Redshift and in Redshift and Houdini specifically, and randomization of shaders. If you, for example, wanted to randomize leaves or whatever, right? And one of the things that's unique about Houdini and Redshift is most people in Houdini, they use the copy stamp workflow when they think of instancing with Houdini. And unfortunately, for third-party renderers like Redshift or Arnold, the copy stamp workflow doesn't work. It doesn't actually make real instances. You're creating unique geometry, so it eats up a ton of RAM and VRAM in Redshift's case. And so all those tutorials that people see for Houdini about copy stamp and copy to points and all that stuff doesn't work. And so you have to use a different method. And so I'm going to go over that in Redshift, and I'm going to go over a little bit of randomization to your objects, how to copy instances or proxies or whatever. And I'm also going to cover how to add variation to the shaders so that they randomize based on your instances. And so we'll look at two methods of doing that. One is using user data, which is my preferred method, but there's also using style sheets. And so material style sheets is a different method that also works. So anyways, we've got this blank brand new scene, and so let's start off with a Redshift ROP just so we've already got something going. And let's turn on brute force. Let's get automatic memory management turned on, and cool. So we've got this super basic scene, and let's actually drop down a Redshift sun. And so okay, now we've got our light up here, and let's just do that. And so for starters we'll do instancing, and so let's drop down a sphere. And so we've got this sphere object here, and we'll just we'll add just a basic RS material. We'll drop this down, and we'll just call this sphere matte. Okay, cool. And we'll just apply that to our sphere. And let's quick bookmark this. And if you don't know how to bookmark, just hold Control and press a number key. So if you press Control 1, we set a bookmark for this area. And so if I go, for example, inside the sphere, and I hit Control 2, I've got a bookmark here. So if I press now just the number key, it lets you jump back and forth. It's convenient. And okay, so we've got the sphere. Let's turn it into a polygon mesh, and cool. So we've got this little sphere, and we want to instance this object onto some points or something. So let's first make a grid. Actually, let's make an instance node. So like I was saying earlier, in other tutorials people will do something like I don't know, grid, and they'll use a copy to points or something. And so this is how you would do this in Houdini using mantra. And so let's plug that in here, let's plug that in here, and then cool. So this is what most people would assume is the way to instance objects. But unfortunately, like I said, Redshift and Arnold, any other renderer, this technique only works for Mantra, because Mantra knows, oh, these are instances. Redshift, on the other hand, thinks every one of these spheres is unique geometry. And so what ends up happening is that right now it's spheres, so it's going to render quick. It's not really a problem. But if this was tons of heavy geometry, so right now, yeah, it's it's not a problem. It's just a couple spheres. It's probably a couple million polygons at the most, not even million, thousands. And so obviously it's loading quickly. But if this was trees, this would slow down Redshift tremendously. And again, that's because Redshift doesn't know that these are instances. And so the only way, unfortunately, to do this is you need to do it with the instance node. So let's pause that. Move that out of the way for now. And so let's go back in here. And we have to delete these. And so we're back with our plane sphere. And we have to do this with the instance node. So hit tab, start typing instance, and you'll get the instance node. Now this node, Redshift actually can detect as instances anything that's scattered using this node. But in order for it to work with Redshift, you have to make sure that the instance node has the object parameters attached to it. So click this, and we'll get the Redshift OBJ, and that's where you get the settings for instance and instancing attributes and stuff like this. So this is all automatic. You don't have to do anything. Basically, as long as you attached the object parameters to instances, or to the instance node, or a node that you'll be instancing with, because there's several methods you can use, it will work right out of the gate. And so now that we've got this node drop down, and actually let's on the camera, let's put camera parameters, and let's just turn on photographic exposure. Let's overexpose to 0.8, allow the desaturation because it looks better in my opinion, and a black crush of 0.2. This is usually like my default tone mapping right out of the box. It works pretty well. And okay, so anyways, we've got this sphere. The sphere could be anything. This could be a proxy that you loaded in. It could be whatever, right? So if you wanted to bring in a proxy, you could just click on proxy and it'll build one. But for now, we're going to keep it simple with just a sphere so you guys can get the concept. And eventually, I'll show an example using a tree. And so we go into the instances. Let's delete this line that it starts with. And in our example, we'll just use a grid. You can use a terrain, you could use whatever, right? And you could scatter on it using the scatter SOP. So for example, if we use scatter, it would scatter all these points, and you could add more, less. You can base it on paint. You can paint the points in or out. That's a little more advanced. Some of you guys that are Houdini users already kind of understand that stuff. So for now, I'm just going to keep it simple, a grid. And we're going to use points. So a point for every grid, which is basically all the vertexes, the vertex points, as you can see, inside this grid. And so, pretty simple. Nothing fancy, really. We're just going to keep it simple for now. And so, now how do we get this sphere to get instanced to all these points? And so, the way you do that is right here under the Instance tab on the Instance node. It has an option to say Instance Object. Click that, bring up this menu, and you'll have, whatever object you want. And so you could click Sphere. So you might be wondering, okay, why is it not showing anything in the viewport? And so the reason is, under point instancing, you have to turn on full point instancing. And boom. So we can hide our original sphere now, and let's make these a little smaller. So let's decrease the uniform scale a bit on the sphere. Something like that's fine. And okay, so now what's happening is we're actually using instances. And so this time, again, Redshift will load it, but it's going to be a lot lighter. So and one of the things, you might sometimes have to refresh the render, because it kind of bugs out when it uses instances. Sometimes it doesn't detect that you changed it, and so now it's working. And so let's rotate the camera around. Let's turn off bucket mode, and we'll just use progressive. And so cool, now we've got all these little spheres instanced around, and it's relatively quick, and these are true instances. So now the question is, okay, how do I add variation to these instances? And so let's pause the progressive, move that out of the way again. And one way, and in case let's say you want to work on the spheres, you want to see things at the sphere level, and unfortunately once you're inside the instance node, you're not seeing the spheres, you're not seeing the objects that are being instanced across the surface. So in order to remain at that level, go up to the top and pin your viewport. So there's this little pin, click that, and now no matter where you go, it's pinned at the top level. So if we go in here, we're seeing the spheres rather than points. And so we can see the influence that we have. So now if, for example, I do a scatter and we plug that in and we go back, oh, guess it's bugging out. What's going on? Let's try that. Huh, strange. Oh, it's because it's scattering on. It's not a grid. Okay, so let's turn that into a mesh. There we go. Yeah, my mistake. And so now if we reload, so now we're using the scatter. Yeah, because the grid originally I turned it into points, so you can't scatter points onto points. So I had to turn it back into a mesh. And so now if we change the scatter count, as you can see, in the viewport and in our render, it's adjusting live. And like I said, there's a lot of different methods to scatter and influence the way something scatters on a terrain, for example, based on how you paint it or elevation. There's just a bunch of different methods. Or even if you use the Houdini terrain tools, there's actually, so if we type in HF, you'll see, and I cover the terrain tools in another tutorial, but inside here there is usually, let's see if I can move the tab up, HF, expand, noise shrink, project, remap, scatter. So there's a height field scatter node, and so what's cool about this node is it lets you scatter on a terrain based on different things. So like the height based on a mask that you made, and erosion mask or whatever, right? And so like I cover this in how to make these masks in that previous tutorial. But like I said, for this example, we're just covering instancing and variations and stuff. So okay, cool. So now we've got the scatter of these objects, and let's say we want to add variation to this. So let's say we want to randomize the scale or something. Start typing attribute rand or rand, and you'll get attribute randomize. So that's what this little node does. And it lets you randomize values different ways. There's scale, you can randomize the color. There's a CD. Different ways of randomizing, basically. And so one of the things you could do, and I recommend you look up some of these attribute names, some of the basic attributes. You can find some of these if you type in VOP, and so you get an attribute VOP. And if you ever need to quickly remember what some of those attributes are, you can just go in here and they're listed inside the geometry VOP. So you'll get P for position, V for vector, force, age, life, ID, CD is color. And so you get all this information, PT number, position number, etc., etc. And so that's if you ever need to remember some of these attributes if you're new to Houdini, and all that information's in the documentation. So I just realized that a sphere actually isn't going to work too well for us because it's round, so you won't be able to tell if it's rotating. So let's go in here. Hey guys, so unfortunately I had a crash right before, and so I paused the recording and cut that out, and I didn't save the last scene, so now I've kind of had to rebuild it again from scratch. But we're back to where we left off. Just the amount of scattered objects is a little different, and but it's overall back to working. And so anyways, where we were leaving off is basically to show the randomization of the object rotating. I need a different object because a sphere basically isn't going to work for this. And so I just realized that. And so let's try a different type of primitive. A box could work. Let's just do a platonic solid. And we'll do a tetrahedron. So let's delete the sphere. And so now we've got these tetrahedrons. So this is a little more obvious to give us a direction. And so anyways, let's rename this to just tetra. And okay, cool. And so now to add some variation to this, and let's move this out of the way. Let's go in here. So we've got the scatter. So where we left off was we were going to randomize the objects. And so first let's go back to the tetrahedron, and let's make sure we got a normal on this, just to make sure everything's, even though we might have one, it's just a good habit to always have a normal node at least added. And let's go back to instances. So we've got this attribute randomize, and we want to do it to the points because that's what this is. We're scattering onto points. And so if we plug that in and we change this now to n, that's normal, we've got this variation going on. And again, like I told you guys, you could always type in attribute vop, go inside here, and you'll see some of these things. So like n for normal, vector normal, stuff like that. It just helps you remember some of these these attributes that you might need to use. So anyways, let's delete that. So there's different ways you could add variation. There's just tons of stuff that I could go into here. That's just way too much. And for now, if you just want, for example, let's say these were trees, obviously you don't want them to be tilted sideways. You just want a rotation from the y-axis. And so think of the minimum value and the max value as this is x, y, z. But these are quaternion calculations, so what you need is 4 dimensions. Put a 0 here, 0 here, and let's try, I don't know, 5. Let's look from above. 5, no, that's in the wrong direction. Let's try 5 here, 0 here. Huh. 5 here, 0 here. 1, 1, 1. What's going on? These are going diagonal, which isn't right. Or is it orient? Ah, okay. Mistake. See, and this is why I like doing tutorials like this, just because you guys get to see everything I do wrong, or I have to problem solve, and that's always something good to learn how to do. And so basically what you want is the orient attribute, not N for normal. And so orient is basically short for the orientation of the object. And so, let's go back in here. So now with the orientation of the object set, now we could do 0, 0, 1, 1. Let's try, I don't know, 50, 50. Something weird's going on here. Why is it not? Once again, something weird's off. 1, 1, 1, 1. Huh. Oh, there we go. Okay. Okay. So, yeah. Okay. So, turns out no capital. Again, problem solving. So, orient lowercase, because Houdini's picky about capitals and lowercase. So, anyways, we've got, okay, now we can control this orientation. So as you can see, by typing that in, a 5 here, we totally changed the orientation. Where's the camera? Okay, there we go. So if we go to 0, and let's type in, I don't know, 360 here, and 1 here. Let's move the camera up here. Why are we not getting anything going on? 1, 1, 1. Zero. Okay, there we go. But it's rotating in the wrong direction. Why is that? Why? Yeah, there we go. It is working. Okay. So as you can see, let's zoom in here. Basically, this is X, Y, Z, and the quaternion. Just leave this to 1. Everything else 0 because this is your minimum. Well, technically, I guess you could go into negative values too if you want. It's up to you. So let's say you wanted negative 360. Positive 360. It gives you the whole gamut, but chances are you're going to be within range. So let's just try negative 5. That might be too strong. And 5. Yeah, it's fine. And so if I start to move this around, you can see that certain ones are randomly rotating basically. Only in the y-axis. So let's say eventually you're like, okay, it's cool, I like this variation or whatever, right? And you're satisfied or whatever, right? And again, you know, just tweak this on your own. You'll figure out where you like it. You could leave this at 0. And so, okay, cool. So we've got, you know, some variation to the angles on the y-axis only. And like I said, if you wanted to change, for example, if this wasn't a tree or something else, and you want to change the their variation on the x, you could do this, or on the y, but we're going to just keep it on, on the z. We're going to keep it only on y. And so, okay, cool. So now we've got this variation going on. And now let's say we want to vary the scale of each one of these, right? How would we go about changing the scale? So here you could do another random attribute, and you can chain these up. And of course, if you're one of those guys that knows wrangling and all that stuff, you could do this all with just an attribute wrangle. But these tutorials are more meant, and I'm not a coding type of guy myself, so these are more tutorials meant for like people that are trying to do this visually or newer to Houdini. But if you know how to type up some vex, then by all means, you know, start writing code. I might show an attribute wrangle later at the end of this that can randomize and do all this stuff, but in one node. But that's more complicated stuff that I think most people don't really have the time. And if you're going to learn vex, you'll know how to do all this stuff anyways. So anyways, let's do scale variation. So just type in p scale, and voila. Now we have scaling variation. And so we have a minimum value of 0, a max value of 1. Let's increase the max value to, let's do 3. And we'll do the minimum. We'll do a minimum of 0.3. Maybe this is too big. Let's go down a little. So cool. Now we've got different sizes based on our minimum and our maximum value. And you could, you know, do these per X, Y, Z, or you could uniformly scale, which is why I did it through here. And by middle mouse clicking the min and the max rather than per angle. And that's all you got to do. So now we've got variation on the y-axis, changing directions, and we've got variation on the scaling. And so again, pscale is the attribute name, and orient is the attribute name for changing the orientation, the direction. And so for this, for orient, all you got to remember is that you need 4 dimensions. And so this is 1, and then you just change the X, Y, Z orientation to whatever you want. And okay, cool. So, and you can of course specify by certain points and stuff like that. So you could paint the attribute. So like if you wanted, I don't know, let's type paint, and we wanted to paint an attribute instead of what's it called? Instead of doing everything like this, we could instead of overriding the color, visualize an attribute, which we can do, and we choose pscale. So let's well, no, I guess we could do a mask, but let's move it this way. And so we visualize our points, and we paint based on our, well, we got to do it on geometry. let's unpin that. So we've got we had to go back to our viewport at this level rather than the top level. And so we have our geometry here, and I don't know, we select this, or let's just select the whole thing, press enter. What's going on here? Why is it not painting? Oh, okay, here we go. Start painting around, and let's increase. What's going on? There we go, our brush size. So shift middle mouse click, and the way it's working, we're visualizing as infrared. You could do grayscale or whatever, right? And so let's draw a line right here. And we were to then, let's do it this way. So now we could see that these points, we've painted on these points. So if we go up, those points are the only ones that got influenced, as you can see by the scale. If we were, let's just scatter more stuff on there so you can get a better idea. Let's go up and repin this, and let's increase the scatter count. As you can see, where we painted earlier is where our scale influence is. And so that's what you could paint an attribute in. So you can paint P scale if you wanted to, or whatever attribute you're feeling like painting, right? And this, we'll go back into this when we do, if you want specific shaders to change where you paint the attributes and stuff like that. But for now, let's just delete that. And let's drop our scatter count because that's way too many. And the reason why it got full again was because our paint was mostly black in areas, and so black basically means 0, so there was 0 scale, and so a lot of the stuff disappeared. And it's just, this is fine. So okay, cool. So now we've got our scattered objects, and if we fire up an IPR, it's working. And it's like, okay, cool. Now we've got our objects scattered, loading up blazing fast, and we could increase this count to, you know, huge numbers. I mean, this is 10,000 scattered of these little triangle things. And I mean, look at this. It's just loading like nobody's business. It's just super fast. And so now imagine if this was unique geometry, Redshift wouldn't be able to, it would take forever because it's too many polygons that are not instanced. But since we're using instances through the instance node, it's no problem. Redshift just eats right through it. So let's keep the amount to this, something like this. And now the question is, okay, we have variation in the way we can scatter. We have variation in our orientation of the objects, the direction they're pointing, and we have variation in scale. And so keep in mind, like I mentioned in the beginning of my tutorial series, these are the tools to build an environment. So if you're doing other stuff, you might, you know, try different methods of rotating and stuff like that. But I'm thinking environment work. So these might, imagine these were trees, right? You're only rotating on the y-axis and stuff. And so, and your scales aren't going to be huge different types of scales. And anyways, so now the question is, how do we add variation to the shader? And so let's pause that. Let's move this out of the way. And let's go to our shader. So we've got our basic shader that we made. It's just a RS material, nothing fancy. A plain RS material. And the question is, how do we make each point have different shaders? So let's just duplicate this. 3, 4, 5. We're going to do this five different shaders. So we've got this one, we'll just say this one's green, this one's orange, this one's blue, and we'll make this one red. And the first one we'll just make it black. A really dark gray. Okay, cool. So now we've got 5 different shaders. So you can imagine these are your leaf shaders or whatever, right? Variations of your leaf shader. And so, and I'll show an example of this later once we actually bring in a tree and we actually start randomizing the leaves. But like I said, I want to keep it simple with just shapes and stuff so you guys can learn. And so now that we have these 5 shaders here, how can we randomize them on here? So our next step is we actually need to build a redshift material. And so we need this because we're going to be piping everything in. And the next step is, I believe, a redshift. I can't remember the name. Where is it at? Oh, there it is. Shader switch. So if you type in RS or shader switch, it should pop up. So right here, RS shader switch. And so what this node does, this is part of the user data nodes, the family of user data nodes. And so let's squeeze this over, zoom in here. And so this shader switch lets you layer up basically shaders you could switch with. And you can do more than just switch shaders. You could switch, like if these were, instead of individual shaders, if these were file textures or something, you could use the same thing. But we're going to switch the entire shader graph setup and for this example. And so let's put in the shader 0 slot. So it goes 0 to 9, so it's 10 total. And let's load these up. And 4. Okay, and so we've got this redshift material right here, and we'll just name this RS random shader. And so this has us needs to now get assigned to our original object. So let's go to our tetrahedron shape, and let's assign this one the RS random shader. Okay, cool. And while we're here, we actually have to apply an attribute so that it knows when to basically randomize the shader. And so we have our object here, right? And what we basically need happen is we need it to randomly change the shader based on just on randomness, like a random attribute. And so since we're basing it on instances, on per instance point, we could do this at the instance level instead of on the object level. So the object has our shader, right, that we're assigning, and since we want it to change for every instance point randomly, what we do is, now that we've got these random attributes, right, we drop attribute random, and you don't really need this many dimensions. You could just have one dimension. Doesn't really matter. You just keep it at default, whatever. And let's wire this up. And so right now it's under CD or color. We need to give this a custom attribute name. So I'm going to just call it random shader. And you need to remember this name because it's important. And so you could set it up by groups, or you could paint in, like I showed earlier, a custom attribute, but we're going to just do it across everything. And so what we have is basically we could do 2 values and do probability, but since we have 5 shaders, what we want is 0 to 4. So let's just do 4. And so what's going to happen is basically it's going to randomly go between either 0 or 4. And the thing about this, though, is that you want integer values. And so now that I think about it, might be better to use just an attribute node. So let's just do an attribute create. This is probably better to do. Well, should we use 32-bit size default value? No, yeah, actually random will work. So now we've got this, right? So it's going to give every point, because we have it on points mode, is going to create an attribute called random shader, and it's going to choose a value between 0 and 4. So, and since we have 5 shaders, that's all we need. 0 counts as 1 or whatever, the first shader. And so if we check out, well, no, yeah, let's just see if it even works right out of the gate. So let's copy this attribute, and in here, let's move this to the side. We'll just do it at integer level here. And so what you do is type in user, and you'll get the user data nodes for Redshift, and we're going to use integer. And the reason we want integer is because it's not a float value. So if we do user data scalar or vector, basically we would get, you know, RGB values, and we don't need RGB values. What we need is basically full numbers. And so we need you know, it to be 1, 2, 3, not 1 point whatever, you know. We don't want values like that for this situation. So that way it knows which ones to switch to. And so now that we've got this in the attribute name that we're trying to give it, we're going to pipe in random shader. And so this is the attribute we created earlier. And as you can see, blue output connects to a blue selector. And so we'll pipe this in. And so now what's going on is our random attribute we created earlier is feeding the shader switch data on which one of these to select. So it's going to try 0 through 4 because those are the random point attributes that we added. And so now if we try a new render, we should be getting something. And something weird's going on. Not quite sure why. Strange. Let's reload this. So what is going on? It's kind of, let's close that. Maybe it's a bug. Huh, weird. Okay, so we've got this. It's a gray, green, yada yada yada, integer random shader. That's selecting 0 through 4. Let me go back to the object. And attribute randomize 0 through 4. Attributes on points. Let's try vertices. Nope. What is going on? Okay, that's weird. Should be working on points. Constant, 2 values inside directional options, global scale, blah blah blah. Yeah, attribute randomize 0 through 4. There we go. Okay, yeah, it was the dimensions. Why? I'm guessing because it's assuming due to dimensions we're getting well, no, I don't know. That's weird. Okay, I don't know. I think it's just bugging out. But dimensions 1 should work. And so if we just keep it in 1 dimension of values 0 to 1, what we should get is, yeah, the variation. So I think that dark gray is kind of making it hard to see. So let's change that color to something else. It's white. Yeah, just makes it easier to see it now. And let's increase the roughness because they're all way too bright. And so, okay, cool. So now you can see that what's happening is, due to the attribute we created, it's randomly selecting through this user data, the random shader data. It's randomly selecting one of these 5 shaders we built. And what's really cool is you could do this for any value. So like, let's say you wanted, instead of switching shaders, you wanted to switch, I don't know, like roughness or something. You could do the same thing. So you can make another random attribute, or you could reuse this one if we wanted, and do another shader switch. And we could, let's plug this in, and we can let's do a constant, I guess. or RS color. So let's do color composite, color change range, or ramp. Ramp would be better. And so let's use a redshift ramp, and we'll just make this black. Let's duplicate this, and then we'll make this one white, so it's super diffuse. So the black will make, we're going to plug these all into the roughness. And so if we do this, and actually this won't work because we need 4, and since this is spitting out 4 values, so let's just make 5 of these just for usability's sake. And so we'll make this one 0.5, so it's kind of glossy but not really, or 0.1. So it's pretty glossy but not all the way, and we'll put that into shader 2. And matter of fact, just for simplicity's sake, what's going on? Come on. We'll use a noise just to drive one of these. So one of them will be being controlled by noise, the 4th. And so now if we plug this in to our roughness, so our reflection roughness, what we'll end up getting reflection roughness, and let's actually just select them all, and reflection roughness. What ends up happening now is we're getting randomized roughness levels. And so let's pause this for a second. So because the quality, the sampling is way too low, so you're not going to really notice it. So let's increase the samples a bit. Let's do 512, 0.003, override. There's no refraction, so let's just do 1024, 1024. Okay, cool. And we'll quickly do a fixed scaling of 300%. So it'll be 3 times larger. And let's go back to our shader. So now if we reload this, it's probably going to be hard to see. But the idea is that yeah, it's probably too hard to notice. But basically what's going on is different objects have different reflectivities values, and so let's increase this grid a bit, and let's see. I mean, you could see it in some spots. Like, okay, like for example, this one's the most obvious. You see how this one's all rough, the reflection, while other ones like this one have much sharper reflections. And that's just because we randomized the let's decrease this to 200. We randomized the reflection values. So if we let's make another material for the ground. We'll just call this ground. Make this dark. We'll make it pretty diffuse. And let's throw this on the ground. And so if we let's zoom in here and look around. Let's try to find something with reflection. Yeah, it's kind of hard to see. Maybe I should have used bump instead. But well, this one right here is the most obvious of the bunch. And so you can see that some of the other triangles are shiny, and this one has noise. And that's probably because it's randomly selecting the RS noise that we made earlier. And so, yeah, back to where we were. Had to pause it for a second. Yeah. So if we were, let's just make two noises. So let's have this noise be fractal, like we had earlier. Then we'll make this one cellular. So maybe we'll see the pattern differently. And we pipe this into 2. So that means half will be fractal noise, half will be cellular. And we fire up the IPR. Hopefully it's visible. Let's do a progressive. And yeah, I think you could see it a little more obviously now. In certain spots. So you can see it here. There's a variation of noise. And different type of noises over here on the roughness, basically. And as a matter of fact, I think we could probably get more contrast out of this if we threw it through a ramp. And so let's actually feed that into that. And so let's crush this so it's even more obvious. Let's reload. I guess it's not really showing up too well. I mean, it's there, but yeah, it's just not, it's not as obvious as we would like. But let's see if we kill the UV space, crunch that down. Since these technically aren't UV'd, I think that's what's causing the problem. So let's really quickly just unfold or unwrap, I should say. And project it. Whoa, what the? Come on. Well, no, I guess an unwrap should do. Let's see what's going on. Did it? actually move that out of the way. Okay, yeah. Just had to make sure it actually did what it was supposed to do. So let's pause that, reload, and then go back to our material. Go to our ramp, type in UV. Okay. Is it even making a difference? What's going on here? Camera. It's hard to see since the objects are so shiny and bright. So maybe if I darken these down a tad. Yeah, I think it's easier to see with the black, like dark grays, darker colors. I think now you're able to see, yeah, much better, the variation on the roughness. And so some of them have it, so you can see. And why is the ramp not working? Let's see. If we try this again, so okay, well, you can see the roughness variation. Basically, some objects are a little more rough. Other objects are, you know, depending on where the noise levels are. And so, if we were to increase or decrease the scale, I think you could see it right there. See what it's doing. So these are the cellular ones. Actually, let's see. The ramp should be working. It's strange. That's weird. It seems like the ramp isn't even influencing it, which doesn't make sense. Is it backwards? What's going on? Huh, that's weird. Alright, well. Oh, there we go. For some reason, it's not, the IPR is not picking it up. I don't know why. There we go. So if I crush the values, it should get sharper. Yeah, so you can see that the pattern of roughness is changing. And then we have this one, which is one of the other half of them are using this and half of them are using this, because there's only, or actually there should be 1, 2, 3, 4. Yeah, let's plug this into the final one. And there we go. And that should basically mean that half of them are going to use this noise. So if we decrease the scale, you can see it right around here. So that the scale is really small, we increase it, and as you can see, the pattern began to change for this noise. And so, anyways, you get the idea now. Basically what's going on is you could use custom attributes that you made to control a shader switch that can control anything being input, noise, ramps, texture inputs, whatever, right? Anything that you can plug into a shader, and then you feed it through this, and it randomly picks one that feeds into a shader, and then a shader can be randomly selected also using some user data that eventually feeds to the Redshift material container, and this is what you assign to your object. And so basically what this means is you can get some really complex big shader graphs that let you randomize all types of attributes and get, you know, real creative with stuff. And it's really neat, some of the things you can do. And so you might be wondering, okay, cool. How can we use this now in an actual project, right? I mean, I'm hoping that you guys are figuring it out as we go, how cool this is, though, that you could plug in all these things. And you can nest a Redshift shader switch inside of another Redshift shader switch. So you can have more than 10 if you need more randomization. 10's a lot, I would say, but you could randomize up to whatever number you need. And the way you do that is basically you have an offset. And so if you needed more than 9 or 10, you would offset this to 10, and then it would go 11, 12, 13, 14, 15, and so on. And so then you would plug that into another one of these. But okay, cool. So this is one method of randomizing your shaders and doing neat shader randomization. The next method we're going to go over is material style sheets. And so if we go under, open up a new panel, and you find the data tree, this is where you make material style sheets, right here, material style sheets. And this lets you select an object and randomize it. And so I'll be covering that next. I'm going to pause the tutorial for now, just so I can save and save the recording and the progress we got so far. So I'll be back. Alright guys, welcome back. Now we're doing the material style sheets method for randomizing your shaders a bit. I personally prefer the user data method, but it's good to know this technique too. It's got its uses. And so where we left off was you need to open up the data tree tab right here. So we've got this open, and it lists your objects in your scene. And so I let's go to the mat. I disconnected everything, so now it's just this white shader. So that's why our objects are white for now. And we're going to just go over how you could have it randomly pick these different shaders. So since we're doing this at the instancer level, since these are all instanced objects, we got our instance here. And basically you just got to right click it, and you just got to click add style sheet parameter. And this will start creating style sheet parameters for your object. And basically, you just go down here, click add style by right clicking this, and now we have a style. And so you can have multiple styles, and we'll layer them up, and it works on a layered basis like Photoshop, where you layer things on top of each other, and so they start to override the previous layer. And but I'll show that as we go on. So for starters, now that we've got our first style, you could add a target, and so this lets you choose the target type. And so these are objects, primitives, instanced onto points. So what we need is point instances. since we're getting the data basically to override per point. And now that we've got point instances set up here, we could do it different ways. So we'll do this next. Actually, let's just override all of them first. And so all we got to do now is right click on the style again, and you add an override. And so the override basically lets you override what the information that's going on here. And there's tons of stuff you could override. You could override things at like the material level, and there's a whole Houdini masterclass on this that's free on Vimeo that just goes in depth into all these different little techniques you could use. I'm not going to cover all that because that'd take another 2 hours. I'm just going to cover like basic material overrides or shader overrides of your objects. And so anyways, that's what material parameter does. This lets you override individual parameters in your shader. But we're going to just click set material. And so what set material lets you do is it lets you override the entire shader of an object. And so we scoot over to the right, and as you can see, the override type is material. And so you have this section called value. You could type in the name of the shader, or you can click on this little box, and that will bring up your material list in your mat context. And so if, for example, we override with ground, which is the black ground we got, and now it's set to ground, and I do a render, all of a sudden all our objects are now the same material as the ground. And if we change that up to, I don't know, randomize 3, whatever color that used to be, and we reload, now it's bam, just like that, we got this color. And so yeah, let's keep it at ground for now. And cool. So let's pause that, move that out of the way. Okay, so now that's overriding everything in this object. All the instanced points are being overridden with the ground material. So now let's say you want to make a different style. You want to influence different points, right? So what you could do is go back up here. It says style sheet. Right click, add style, and now we can do it all over again. Except this time, we're not going to override everything. We're going to override some points. And so there's different ways you could approach this. You could do it by selecting from the viewport, which is really useful. So let's do that. And so now we're in viewport selection mode. And let's just zoom in here, and you can see all these little points. Why aren't they selecting? Are they selecting? Oh. What's going on? Okay, that's weird. Let's go back to the object instance. And why are we not selecting? We're in primitives, edges, points. Ah, okay. Oh, my mistake. I thought we were in points mode. Okay, let's go back to data tree. So right click this, set target from viewport selection, and being in point mode. What the? Yeah, what's going on? Select points. Okay, that's weird. Okay. Let's cancel that. Let's go back up. Let's go to object. Let's just hit enter. Why are my points missing? Let's go back in here. Huh. Let's go to grid. No, scatter. Okay, that's just weird. But let's just select these points, for example. Okay, cool. And let's pin this. So if we go to the data tree, let's do this again. Set target from viewport selection. And now, for some reason, it picked it up. So I don't know why it bugged out there. It's supposed to let you just select them, but I don't know. It's Houdini. It sometimes does weird things. So, okay, now that we've selected these objects, the points, and we right-clicked and chose Set Target from Viewport Selection, you'll notice that it says Point Group now. We've got a condition for the target. So we had this target. Before it was just everything, all the points under here. Now we're going to do point instances, but we're going to choose a condition, which is a group of points. And so here we have the list of all the points that are selected. And so now that this list of these points are selected, these are the ones we're going to override. So now if I right click it, click add override again, and this time we choose set material again, and we go over here. Let's try randomize 1. And so if we fire up another render, voila, just like that, we now have, and like I mentioned, it's a Photoshop style where it layers, except instead of layering on top, it layers downward. So just keep that in mind. So the base layer was everything is going to be ground texture. And then the next style override of these points that we selected in the viewport is now going to use material randomized 1. So, okay, let's pause that. Let's move that out of the way. Let's do another one. Let's, so again, right click the style sheet parameter, add style. And you can name these, you know, so this is like style 1 or style base, style 2, style 3, whatever, right? And so now let's add another target. Once again, point instances, because that's what we're going to override to feed into our instances. And this time we'll add another condition, and we'll do a group. And let's do, I don't know, points 1 through 25 or something. And you could type in expressions, stuff like that, and it'll work just as expected. And so now we got to right click this, add our override. We're going to override the material. This time we'll do 3 and load that up, and boom, just like that. Now we have these blue ones, which is based on points 1 through 25. So if we were to activate the was it display normals, display numbers, it's not showing it. Yeah, display point numbers. What's going on? That's weird. Why are my points not being displayed? Ah, there we go. Okay. So if we were to zoom in here, and yeah, they're really tiny. I don't think you guys are going to be able to see them, but the each of these points is numbered 1 through however many points I got scattered here, 220 or whatever. And basically each point gets assigned a number, which then gets assigned through the shader overrides. The numbers get assigned whatever shader you used. And so this lets you basically control what shaders get applied to stuff really easily. So you could manually select stuff, or you could make a group selection or a paint selection, and then you'll have the point numbers. You can copy and paste them in here, and that's all you need basically. So you could do expressions, PT nums, stuff like that. So this is basically a relatively simple method to switch stuff up. I personally just prefer user data, but both methods are effective and they're good to know. And so anyways, okay, cool. So now that we've got this method down and we're able to control what shaders get selected on what instances, let's apply what we've learned basically onto an actual asset. So we're going to load up the tree asset that we built, and we're going to do some randomization. And so I'll be pausing this for a second just so I can load up that scene. Alright guys, now I'm back. So here we got our tree that we built a while back, and this is a fresh scene. So let's drop down to Redshift ROP. Let's turn on GI, brute force, just for speed purposes. We're not really trying to get crazy. Settings, let's just do 256, 03, or not even 256, 128. And let's just override everything. Light. And we'll just do 256. Oh, no. 256 here. Let's copy that. Paste. Paste. Alright, cool. Let's start the IPR, the render view. Let's see what happens. Hopefully it... Oh, we need actually a sun. Oh, and now that we've got a camera, let's actually pause this. Move that out of the way. Let's look through our camera, lock it back up quite a bit, and let's add the camera parameters. Let's turn on some photographic exposure, allow overexposure desaturation. Let's do 0.8 here, 0.22, and that should be good. And let's also drop down a sun. So let's drop a sun in this angle. Hold control, click light and sun. This should be cool. Let's unlock that, look away, and let's drop down a grid. And let's increase the scale on this to 10. Okay, cool. Let's fire up the IPR again just to make sure everything's alright. Whoa. Our light looks like it's way too strong. Oh no. Not quite sure what's causing that. Let's lock that up. Let's move around. Strange. We should be seeing a sky. Uh-oh. What's going on? Huh. I think I broke it. I think I broke it. What is going on? That's really weird. Let's go to material. Yeah, we've got our mats here. Let's drop down to ground or material real quick, just to make sure everything's somewhat normal. Because I don't know where this light's coming from. And this is why you gotta debug stuff. Huh. Very strange. Very strange. Very strange indeed. Let's jump inside this. Map arc. Yep. Everything looks like it should be there. Transformed right. Why is our sun being weird? Let's just close that. Maybe the render view bugged out. Yeah, wow. There you have it, guys. Bugs happen. So, I don't know why it wasn't refreshing, so I had to completely close the render view. And now everything looks great. So let's drop this down to 100% just because it's faster. And let's actually load up something like ASUS. This is something I wish they would do automatically, that it would remember your location for OCIO, but it never does. Hopefully they'll address this in the future. Let's do P3D60. It's a resolution. Let's check. 720. Yeah, it's fine, I guess. Let's do 150. Alright, cool. And let's look around. Our ground is way too bright, so let's head over to that. What the? Huh. It just deleted it. Go this way. Let's drop this down to something a little green. Let's kill our roughness up to something like 0.75. It's way too shiny. And let's just zoom out. Look for our sun. Let's move our sun a bit. Let's control 1 here. Our sun, let's go up a little bit. Alright, cool. It's good enough for now. And let's actually darken this more. Let's go 0.9. And yeah, scattering stuff on the ground and having displacement and all that stuff obviously will be better, but we're not covering all that for now. You guys can get creative with that. We're going to just discuss now how to instance this tree and add variation to it. So, okay, cool. Let's go back to the object. So now what we got to do is we have to instance this tree. And we're going to just instance it on this grid. You guys could instance on whatever terrain you built using one of the terrain tutorials that I mentioned earlier in the previous class. So for now, we'll just use this and get rid of the add. And so here we could reference this terrain, or we can build our own new setup depending on what you want to do. But we're just going to use a object merge and merge in our terrain. So let's pause this for now just so we can work on it. So let's type in tab object merge. The object merge basically lets you bring in an object from outside of the object you're currently in. So click on this. We'll click on our grid, and now we brought in our grid. And actually, now that I think about it, let's actually scale our grid back down to 1 so they match, and we'll actually scale it here at the object level. And so let's increase this to 150. So if we zoom out, it's a pretty decent sized grid. And cool. So now let's go back up. And while we're here, click on instances. Make sure you always have to turn on object parameters on an instance. Otherwise, Redshift won't know to instance the attributes and stuff. So keep that in mind. Okay, cool. So let's dive back in. We've got our object merge going on, and we're going to do a scatter. Let's plug this in. So if we look at everything, you got all these little dots scattered around. And pretty much at this point, if we were to go back up and we turn on under instance on our instance node, point instancing, full point instancing, what we're going to get is our tree is going to be scattered everywhere. And so, but first we need to actually plug in the tree. So under instance object, we're going to select our acacia, and boom. Houdini, being smart as it is, it knows this is going to be way too heavy. So it automatically does most of the bounding boxes. You'll see inside there's like a couple trees that are actual geometry in there. But overall, Houdini knows, hold on, this is way too heavy duty. I don't want to crash your viewport. So it does bounding boxes. And so let's actually save this a progress in case it does get too heavy and something happens. And let's actually go back up and let's pin our viewport here. And now go back in here. And so right now we've got 1,000 points. That's a lot. For now, let's just do 200 while we're working. And from here, now it's about randomizing stuff. So just like we did earlier with the basic shapes, we're going to now use attribute randomize. So click on this, plug that in. Instead of CD, we're going to do orient. So we'll start off with making them turn around. So dimensions for orient has to be 4 because it's quaternion. And now it's all over the place, jumbled up. But we don't want X rotations, and we don't want Z rotations. We only want Y. So 1, leave this at 1. And boom, 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 boom. Now we've got all these rotations. Cool. Let's build another attribute. Type in rand. Attribute randomize will pop up. Let's plug this in. And we'll just rename this as rand rot. Random rotation. Rand scale. And so for this, P scale, and let's do 0. I think would be, wait a second, P, there we go, not capital. 0 is too small, like now we get like way too tiny stuff, so let's bump this up a bit. It's like 0.5 maybe. No, 0.8. And for our max, we'll do 1.2 or something. And so now we've got rotating trees. We've got different scales on the trees. Let's go a little smaller. It's 0.5. And so now we've got all this rotation and scaling going on. And it's being scattered X amount of times. Okay, cool. Now we've got to do one more. Attribute. Or rand. And this attribute is going to be what controls our shader variation, like we did earlier. So let's click that, and let's just call this rand leaf. And we're going to randomize the leaf colors. And so, okay, let's bring this down to 1 dimension because we only want integers 0 through whatever. Let's randomize 4 times, so 0 through 3. So we'll have 3 not 3. What's it called? 4 variations. And so using this custom attribute that we're writing out. So let's copy this. And let's actually set a bookmark or a quick mark here. And let's go back to our materials. So if I were to load this up, let's save because it's starting to get a little heavier. And give it a second. Now we've got our trees. Pretty neat. And so, cool. Now how do we now get the variation on the leaves? On different trees have different colors, right? And so the idea here is we're going to use the user data. So we've got the leaf 1 and leaf 2 section, and if we dive in here, we've got this data this texture sampler being fed into the material, the diffuse and the translucency color. And so what we can do is now control this with the shader switch. So we start typing shader, and you get the RS shader switch. Just like we did before, we'll plug in shader 1, and we'll plug that in here. And let's do another one for the translucency aspect. Let's move that here, move that into 0, and now we've got that. Let's cut this. I don't know why that's there. And okay, cool. So now we've got the 2 shader switches, one controlling the translucency of the leaves and the diffuse. Nothing has changed because it's the same data. Nothing's changing yet. And so, like, I don't know if you guys remember now, but we have these selector slots. So what we have to do now is use the integer, the Redshift integer user data. And this is where we put our attribute we created earlier. So paste it in, rand_leaf, hit enter. And now we plug this in to our selector, and now it's controlling stuff. Obviously we're getting these white leaves because white is the default. So most leaves, the leaves between 0 and 3 are now white, and then only 0 is being colored. So now what's really cool is, let's just move this out of the way somewhere. Move this way. We can make color corrections, or yeah, color correction I guess would work better. Let's do color correct, and we'll plug that in as an input, and we'll do this as a yellow. And we'll plug that into shader 1. So it's not going to do anything because we haven't changed the parameters here yet, but let's increase the saturation just so we can really see how obvious it is. And let's shift the hue, so now we're getting different greens, red, so we got this yellowy kind of color. Okay, and let's drop the saturation back down to 1. And now we got to plug this back in to here. And cool, just like that. Look at that. Now we got this yellowy tree and these green trees. And so let's move this out the way. And let's move this out the way. Up here. It starts getting a little confusing. And so let's make another one of these color corrects. And we'll call this one red. And so we'll plug this back in, move this over here, plug this into slot number 2, and this time we'll color correct this to be reddish, or on the red side of things, or brownish I guess. And let's 2. So now we've got this browner looking one, these yellower ones, and this green one. And let's zoom in here real quick just to see actually what's going on. And since there's two, if we go back up, there's two leaves. That's why we're getting this kind of weird variation. So I'm going to have to copy these and paste them into the second leaf slot. And so, cool. Now we've only got this one last tree here. So let's drop another correct. Input that. And let's call this one dark green. And now plug that into number 3. And this time we'll move it this way. And maybe decrease the levels. Maybe increase the contrast. Drop the gamma. Cool. Okay, now we got this dark green. And of course, we could further color correct each of these for the backside like we did here, where we might increase or decrease saturation, blah, 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 you know, and take this further. But for now, let's just keep it a little simple. And so let's move this and this over here, and let's copy these. Let's move up a bit, go to leaf 2, let's paste that in here. So now we've got the texture sampler, and we just drop down the shader switch again. I probably should have copied and pasted this too, but oh well, too late. And let's duplicate this. So now we've got 2. And so let's plug in the user data in here. Let's plug this into 1. Let's plug in or 0, 1, 2, and 3, and then plug this into the diffuse, and that changed things drastically because these are the other leaves. And let's plug this into, oh, not the selector. Let's delete that. Actually, let's plug that selector, the integer data, into there. And then let's select all these. And Houdini's pretty cool that it'll connect them all in the order you click them in and stuff. So okay, and then now we'll plug that in. And okay, so now this red is really going nuts. Let's check in on this. Let's desaturate this because it was at 2. Maybe drop the levels a bit. Kill the saturation even more. Maybe move a little closer to the yellow. Let's zoom out. So yeah, we've got totally different colors. We've got the regular green, we've got this reddish one we were just touching, we've got this yellow, and yeah, using this basically you're able to add variation to all your shaders. And keep in mind this is all still one big shader network that's being controlled by the attribute we created, randomly scattering them around. And so anyways, so let's say you're like, okay, now how do I control the percentage of these? Because right now every one of these has an equal chance of being scattered here, right? And so there's ways you could do this with scripting the way that you created the attribute, but in my opinion that's just like overkill when you could just do it really easily. And one of the ways you could do it, if you think about it, is instead of having 0 to 3, have 0 through 9. And you might be wondering, well, why? Well, basically what this lets you do, and let's reload this so we can get more of the white ones back in. And so what basically you could do, which is kind of like a hack if you think about it, the shader switch has up to 10 shaders. You can actually hook up another shader switch into a shader switch and add another 10, but we're not, that's way too many shaders for our example. And so let's say, okay, I only want 10% of these to be this red, and I want them 20% to be this brown. So how can you do that? Well, it's simple, really. All you got to do is plug it in one time for 10% and have the rest of the slots filled 2 times for 20%. So you're kind of doubling it up. So for example, where's the base texture? So for our example, oops, let's kill this. So for our example, let's actually just kill all of these, so we get basically all white ones, and we'll get a few that are going to be green. And so we've got this green, our base, right? Plug this in. So right now, if we plug it in just once and once, 1 in 10 of the trees, a 1 in 10 chance, a 10% chance that the tree will be this color. And the rest, because they're all white on the options, the rest are going to be white, 90% chance. So to increase the odds without having to do any scripting or code work, just plug them in. So now it's 20% chance. See? Now it's 30% chance that we're going to get green. And there's variation in there because leaf 2, and I haven't cut those out yet, but you get the idea. And so actually this shouldn't be this way, it should be color correct. And so right now we have a 30% chance that it's going to be this color, right? But let's say, I want a mostly green, so I'm going to plug in, I want 60% chance that we're going to get this green color. And so now 60% of the plants are going to be that color. So let's actually, and you can't really notice it too much because I have to go back into leaf 2 and do the same thing here. So if let's just kill these and kill these, and now we've got 1, 2, 3, 4, 5. So now it's 60%. And we do the same thing up here. 1, 2, 3, 4, 5, 6 actually. If I do 6, it's actually 70% because 0. So now 70% of the trees are that green color. And so now I can make 20% this yellow and only 10%, the last percent left over, red. And so let's do that down here. 20% yellow, 10% red. And let's go back up. Let's go to here. So 20% yellow by plugging it in twice out of 10, you know, it's just math. And twice in here. Let's do red 1 time and 1 time up here. So now we're getting 70% of all the trees are going to get this green shader. 20% is going to get this yellowy brown shader, and only 10% is going to get this red. And if you want to decrease the percentages, of course you could just do it the same way, but just nest another shader switch inside of a shader switch, and that will divide it so that these will be worth, instead of 10% like they are now, it'll be 1 out of 20, so it'll be 5%. And yeah, that's just a neat little workaround. Instead of having to type in any vex or any code or anything like that, you can just do it all visually at the shader level. And okay, cool. So let's go back up now, and let's scatter some more objects. So let's go to our instances and increase our scatter count. Let's go to 800, some quite a bit heavier. And just like that, I mean, instances load up so quickly, and just Houdini and Redshift just tear right through them like no problem. And so, yeah, obviously the colors are a little too bright and weird looking, but I'm not trying to go for realism here. I'm trying to show you guys how it works. So you wouldn't be able to see a slightly yellowy green compared. It's easy to see these colors. And, you know, just like this, we already have a good amount of variation. If we just look at it, we've got totally different trees and totally different shaders. The trees are all the same tree, but we have variation because of the scale is changing, the rotation's changing, the shaders are changing. So now imagine if you did this, you know, many more times over, and you basically would be able, you know, with more objects, more stuff, you basically are able to layer things up and very quickly start building some cool variation and stuff. And so yeah, let's I think that kind of sums up what I was trying to teach you guys. In general, everything is explained. And so I'm going to pause this for a second and work on it a little bit, and then we'll just fire out one final render. And keep in mind that the user data technique works on other stuff, so we could load in our VDB that we made in that cloud class and scatter it the same way and have variation on the shader, all the same way. And that's the really cool thing about user data and custom attributes. And like I said, you could do this with material style sheets. That method that I showed earlier, I just personally prefer user data. I feel like it's just more powerful. I don't know. I mean, I don't. At the end of the day, I don't think it really is, but I like it more. And so, yeah, let me pause this, and I'll be back. All right, guys, just spent a little bit of time adjusting the shaders a little bit and getting the lighting different. Threw an HDR in there, and yeah, that's about it. And I increased the scatter count and the plane size. So if we zoom out, I mean, look how fast this is rendering. It's pretty much instant. This is a huge amount of a huge amount of polygons and stuff like that. And it's blazing fast thanks to basically how it's all instanced. And yeah, if we come in here and rotate around, something like 4,000 or 5,000 trees right here. And so just like that, relatively quickly, you can get a large forest with some decent variation. And this is, again, one tree, only one tree. And with just one tree, we've got what looks somewhat like a random jungle. So basically, if now you were to make a terrain, add grass and little bushes, different types of trees, and scatter them all together, you would get a pretty convincing shot. And that's basically it. That's the power of Houdini instances with Redshift, and using the scatter, simple scatter SOP, random rotation with orient and p-scale, and then using a custom attribute to then power our leaf shaders to randomly add variation using the shader switches. And then we control, the percentages we want variation in by just doing a simple little hack by plugging in everything. And hopefully that gives you guys a good idea of what's going on. And let's just fire off a final render, because why not? And I'll save this file out. I'll save out the previous file with the basic shapes showing the user data, and also the material style sheets file. So you guys will get all three of those files, so you can check out how I did all this and go through it as you're watching the tutorial. Hopefully you guys, experiment with these things yourself and then make some really cool scenes on your own. And hopefully these fundamental concepts in how to get user data for variation. And again, user data is just super powerful. And the shader switch and all this stuff, you could do just crazy amounts of things with this. This is just an example with trees, right? You could be doing this with vehicles or characters or buildings or whatever. Just tons and tons of possibilities get opened up. And the options are, I'm not going to, pretty much limitless. And again, if you're in another application, the same things apply. Attributes can be loaded up using user attributes to feed shader switches. The cool thing about my Houdini is that it can do all this plus material style sheets. It's an attribute driven application, so it really shines with this type of situation. It's just really powerful stuff. Currently, Redshift does not read the mash per point data, so using it for this type of thing is kind of complicated. One of the developers said they'll be updating that sometime soon, so when that happens, I'll probably cover something similar in Maya. But I'm mostly now focusing in Houdini just because I myself am transitioning into Houdini. I used to be a Maya guy. I really like Maya for a lot of stuff still, but Houdini's just been improving drastically, and it's just an amazing application. So I recommend everybody that's watching this too to hopefully keep learning Houdini. I think that it's definitely the future when it comes to 3D apps, and its pricing is great. You know, only $250 for the Indie, $4,000 for the FX, and combo that with Redshift, and then it's got Mantra built in for whatever else you need. I mean, it's a win-win all around. And so, yeah, cool. Now we've got our super basic forest with a whole bunch of little variation in shader colors and stuff, and you know, it's just a plain brown ground. Obviously, like I said, you could really go crazy with this if we had a terrain with movement that, you know, was carved out, and we had textures on the floor and scattered grass, and I might actually cover grass using fur systems one of these days in one of the tutorials. And but yeah, hopefully this gives you guys the tools necessary to build your own scattered scenes like this and really take advantage of randomness in instancing for direction, scale, and shaders. Alright guys, thanks again for all your support. Feel free to fire any questions my way if you have any questions, and look forward to our next tutorial. Thanks. Hey guys, just wanted to quickly show something that I did. Basically, using the techniques that I went over, I just imported a terrain I built a while back, and scattered tons of geometry all over it, and yeah, so you can see there's just huge amounts of instance trees, and I just quickly did a little I don't know, random boxes thing just to make something cool floating in the sky, and used an HDR and just had a light source and added a little bit of volume fog and attenuation from the light. So here's the result. And as you can see, you know, it's pretty convincing from a distance. You know, there's a lot of variation, and in terms of foliage, it feels like there's a lot going on, really. And even though when you really get in here, you'll notice that it's really just the same tree stamped everywhere with a little bit of rotation and scale differences and shader variations. And so, but that by itself from a distance really helps to sell the image and break up the shape and feel like it's, you know, this is like some crazy dense jungle, you know. And so, like I said, this is just one tree. So imagine, you know, once you actually take some time and prepare a proper scene and you got different trees and different assets and stuff, you'll be able to get some really cool results. And so, again, I'll be saving this scene out for you guys, and you guys could open it up and check out everything I did and explore. And that's about it. Alright guys, till next time.